Okay, next problem. Cosine squared equals 3/4 from 0 to 2 pi. So before I get started with this problem, you might be thinking, you might have seen a couple of these videos so far, you might be wondering, why doesn't he just use a unit circle and just grab the value off the unit circle? Well, that's because for those of you going on the calculus, you're probably not going to have that unit circle available for you. So I'm trying to show you a way to do these problems that don't involve just grabbing a piece of paper and reading the value directly off and that's it. We're trying to work with methods we've done before, so that's why we're using our table that we had before, and also we have reference angles. So therefore you don't have to memorize all the values all the way around the unit circle. These are really the only ones you want to make sure you memorize, because if you know these, then you can find the answers in the other quadrants as well. So again, particularly for calculus, you want to make sure that you definitely have this memorized, because you're going to be referring back to that a lot in the next class. Okay, so with that, let's move on to this problem now. Cosine squared is equal to 3/4. We're solving it from 0 to 2 pi. I want to solve this for the trig function. I want to solve for cosine. Because there's a square there, that means I need to take the square root of both sides. Over here, we have plus and minus. So square root of cosine squared is going to cancel and you get cosine x by itself. But over here, we actually get the square root on top and square root at the bottom. You can do that separately. And we're going to get two answers. We're going to get positive square root of 3 over 2. We're going to get negative square root of 3 over 2. So this time I want to find any place where I have a positive or a negative square root of 3 over 2. So square root of 3 over 2 comes off of my table right here. That's going to be 30 degrees. So I'm going to do that in degrees and convert to radians. Cosine 30 degrees, root 3 over 2. So that means that right here at 30 degrees, that's one spot where that's where the x value is going to be square root of 3 over 2. So one spot in the unit circle is going to be right there. Now, if I'm looking at, again, I'm going to consider, write these out separately. Here's a positive and also here is a negative. I have two. Let's do both of them for positive square root of 3 over 2 first. Then we'll do both of them for negative root 3 over 2. So here's one answer. 30 degrees right there. That's positive square root of 3 over 2. And then we know that down here is another place where the cosine is also going to be negative. And I have 30 degrees down there. So 30 degrees going up, 30 degrees going down. That's going to be two places where the x value is going to be positive square root of 3 over 2. Because again, the reason why we know it's 30 degrees, because we got that value from the table. Cosine 30 is root 3 over 2. So that's the angle we're dealing with here. Now, we also want to look at where cosine is negative. Now, we already talked about earlier that cosine is negative in these two quadrants, which means that I'm actually going to have an answer in all four quadrants here in this case. Now, all of them are going to be using my reference angle of 30 degrees. So this right here, this is 30, and this here is also 30. So I have one in every single quadrant. 30 up, 30 down here, over the 30 there, and I have another 30 over there. I have four different answers I'm going to have in this problem. So let's write these answers out. So first of all, for sure 30 degrees is one of my answers. Okay, going up there. If I go down this way, 360, I'm going subtracting 30, going that direction. So that means that I would have 330 is the other answer. Okay, so these would take care of the positive version. Now let's take care of the negative square root of 3 over 2. Here is, to go over this side, I have 180. Subtract 30, that's 150. So I get 150. And then I have one more, which is going to be 180 plus 30. So 180 plus 30 is 210. So now I have 210 is the other one. These are all the answers written out there in terms of degrees. And now I just have to go back and convert all those over into radians. And I can use my formula. I'm multiplying all these by pi over 180. So now if I were to do that and rewrite them, well, 30 degrees I have right here. That's going to be pi over 6. So I already have that one. Pi over 6 is one of the answers. Okay, and then if I go over to here, that would technically be pi minus pi over 6. So that would be 5 pi over 6 there in that case. And then I have pi plus pi over 6. That would be 7 pi over 6 over here. And then this one's going to be 2 pi minus pi over 6. And that's going to be 11 pi over 6. So I actually kind of did that by turning the 30 degrees into pi over 6 and turning this into pi, and I basically did everything off of that. So that's another way you could do it. If you don't like working with if you don't want to work with degrees and then convert later, you could have actually just started with pi over 6 here, since we have to be in radians anyway. And if you do that, that means that this would be 2 pi minus pi over 6. This is going to be pi minus pi over 6 and pi plus pi over 6. And that would get you all these values as well. So you can do either or. You can either convert all of them separately, or again, you can start with pi over 6 and do all the problems that way. But mainly you want to make sure they're in radians, because it says that the answer's got to be between 0 and 3 pi. So we have 4 answers here in this one.